Hey everybody, Tim here again. It's Sunday, came in the shop here to take care of some painting some brackets and stuff for my air conditioning conversion in my Chevelle. I've not posted any videos on that car, I will later on. But over last week, like last weekend and this last week, I put a strut front end on this Vega wagon. I built this car for a friend of mine about 25 years ago when I lived in Florida. We were going to race it together. He ended up moving to Alabama, took the car with him, which was fine. Originally built this car as a 3/4 chassis car, had a stock Vega front clip on it. And we built it for a small block. Gonna build like a 630, 650 car with it, something slow, just to bracket race and have fun. And when he got it up there, he decided to put a big block in it. Well, he was also a fan of big wheelies, so it destroyed the front end of the car. And since then, I rebuilt the car, built new A-arms and stuff, straightened it out so we could get it realigned. And through the years, it's just gotten so far out of whack that you couldn't align it anymore. A-arm front end and a little car with a big block, they don't fit. The car right now has, I believe it's a 565 in it right now, new motor. Before I get way into this, I want to thank Ronnie and Kenny and Doug for helping me do this car. They came in and helped me with a bunch of little odds and ends stuff, so I made it go in a hurry. So anyways, I'm going to show you a little bit about the front end of this car with the struts, give you a little background there, and maybe this will help you guys when you're working on your car. So here we go. I'm going to try to get in here close so you can see. What we've used on this car is the newer AFCO style strut. Love them, absolutely love them. This is a 5-inch stroke strut. Works good for like bracket cars. I mean, they're designed for fast cars too. And then I developed the brake kit for it so that we could put a bolt-on wheel. The strange strut comes, I think, currently spindle mount only. And for a heavier car, I absolutely don't recommend spindle mount wheels. They're just, the brakes are real small. Brake kits were designed for like comp and pro stock. Real lightweight cars that use their parachute to stop. If you're not using a parachute, that's not the way to go. This has got like a Mosier caliper and rotor and hub assembly that I developed before I left. We were going to put these on another car, and then the chassis builder decided to go another route, which is fine. Everybody's got their own thing. But I used these on Rocky's car. They were there, and I felt that with AFCO's backing that they needed a good shot, and we're going to give them to them on this car. Like I say, this car was originally, you can see all the new tubing. I left the down tubes and spliced them there. There's a internal splice there, and then in the frame rail, if you can see it, an internal splice down there. Those were the original rails that butted into the back of the control arm assembly, which of course I threw away. The rack came from Jags. It's a like 70 to 72 pinhole rack. I use that on this type of vehicle. Actually, I use them on everything. Like if I'm building a control arm car, if I'm going to use a rack, my Camaro has this type of rack on it. They're just handy, easy to mount. Then the lower control arm kit, we didn't have. That came from RJ Race Cars, and the tie rod kit as well. You can see it's got a swedge tube that slides over the original tie rod, and you just sort of, I plug weld it, cut it on a taper, plug weld it, I cut the original tie rod off, leave about 2 inches past where the boot sets. And like I say, the mounts, they're not like a typical strut mount because I wanted to use the original tubing. Typically that down tube that came from the dash bar and like the A-pillar bar down here I would butt into that cup on the top of the strut. The cup also come from RJ race cars, by the way. But with this, since it was that far away, I had to use like a piece of heavy wall 1 5/8" tubing, and then I put a 1-inch heavy wall gusset in it. To get to this point here, what I did with this car is I had Rocky measure outside to outside of tire width because I wanted to get the wheels in the same location they were. Okay, I knew that dimension already. So I had Rocky measure that for me, and then I just figured back like from the outside of the tire to the inside of the hub, and that gave me my hub to hub dimension that I could set up on my jig. So I knew where that had to go. So that basically located the struts for me. On the side of the car, I'll swing around this way. We set it on this jig right here, another one of my jigs. And off these 2x2 cross members, we had uprights that mimic the height of the car. So we know we're like 8 inches in the back, at the back of the rocker, and 7 inches at the front. So I set the cross members where they needed to be, cut the uprights and tack welded them, so when the car set down on the jig, those tubes went on the outside of the pinch weld, so I could tack the pinch weld to that upright tube. Therein, then that allowed me to determine where the front end went on the car. We measured that distance on Rocky's car. Come over here. As you can see, we measured the ride height, and then we measured the distance from the face of the rocker to the center of the spindle on the existing car, okay? Because I had those dimensions. It gave me something to start with. Then what I did is I put a tubing cross member, and it's not on here, but I can give you an idea. I put a tubing cross member on the jig in relationship to the front axle center line, and then, like doing reverse engineering or my back measurements, I bolted the spindle to this jig. Okay? And basically it's just a spindle nut. The spindle goes through that with a hub on it, and the spindle nut goes on the outside, and that holds my strut at the right angles. Okay? And I also, with this type of jig, I make sure that it's the rotor's plumb and square to the jig. And also, I set that hole there, the spindle center line, at 12 inches off of the my jig, so that I knew that that was the wheel center line, because Rocky runs a 24-inch tire. A lot of guys will subtract a 1/2 inch for tire compression. In this kind of stuff, in my opinion, there's no sense, because there's so much travel in the strut, but to each their own. Okay, so that controls the camber angle, which is top of the tire in and out, okay? That fixture does. Then for caster, I lean the struts back 10 degrees. You want typically like 10 to 12 degrees of caster in the strut front end. Remember now, this is just a bracket car. Bracket car, super street car. You know, this is not a 200-mile-an-hour top sportsman car. Some of those other guys got a fixture that just locates that top cup off their jig, but I don't have that. And I do so few strut front ends that there's no sense in that for me, because I can use the same jig for an A-arm front end too. Okay, I got the strut leaning back 10 degrees. I got the proper amount of camber in it. The car set at ride height, okay? The next thing I determine is compression, where I want that cup at on my strut. Typically, I compress everything 60%, so that you've got like 40% of compression and 60% of extension on the strut, okay? Being this is a 5-inch strut, that made me determine that I had 2 inches of shock shaft showing. So what I did is, you can see that little white tube in there. I cut a 2-inch long tube and put that in the strut just to space it so that I knew that my cup height was right. Once I get all that stuff set, then I start tacking up my upper cup. I put that heavy wall piece of tubing in there, and then I put the gusset in, and constantly checking for plumb, for level, for square, because you can, like tacking and welding, you can move this stuff all over the place and get yourself way out of whack. Okay, once you got all that done, I got that done, tack welded together on both sides. I didn't finish weld anything, okay? Let me back up first. When I got the car on the jig, okay, the front end, we cut the front end off the car, as you can see here, and then I put the frame rails in. And as you can see, the frame rails kick up because on a typical strut car, the lower frame rail is straight, okay? But the car would also be 3.5 inches off the ground. With this car, I didn't want that frame rail down here. I didn't want that sticking underneath the gravel shield. So I figured out where the rack was about going to mount, and then I kicked the frame rail up so it's just above that, so I could get, as you can see, my front end mount in there. I could get that down in the bottom underneath all that, because I still got to get a radiator in this car. And that's how I determined my frame rail height. Because, like I say, if I'd have put this thing together with flat frame rails, the frame rails would have hung down 4 inches below the gravel shield, and that would have looked stupid. So that's why I did what I did here. Then all I did is like put my sleeves in there and determine what I needed here for my upper support tube, and got all that fit together, and then put the cross member in it, tack the cross member in. Okay, so we're that far. We've got the frame in the car, we've got the upper strut mounts done, all that's tacked together really well so it doesn't move around. Then it helps me determine my lower control arm assembly, like my lower control arm and my brake rod. The back rod is a lower control arm, and then the front rod is a brake rod. Keeps the wheel from moving backwards and forwards. Typically, I put them anywhere from a 4 to a 5 degree downward angle from the strut towards the frame rail. Okay? Once I figured that out, where I wanted that stuff to go, I put my heim joint in my tabs. I use like heavy duty shock tabs on the bottom there. Then you can see, I'm going to try to get you in a little closer. You can see them there. It's just basically like a 3/16 shock tab, and they're gusseted, of course. Well, what I did is I put all that together where I wanted it, and then held the angle finder on my tube to determine the length of it, and then I've just marked along the edge, cut it and drilled it and tacked it in place. That got me where I wanted my angle there, and I did that on both sides. And if you look, it leans back a little bit. I typically move that tab center line 1 inch back from the spindle center line, so that it's a bigger triangle. So if it leans back like that when you're on the brakes, it just helps add a little bit of strength to it, keeps that tube from bending. Then on the front, what I did is you need a few things here. Like I say, bigger triangle the better. You want to try to keep this point, the center line of that heim, and the center line of that heim parallel with the frame rail this way. And that control arm has to be the same angle. It needs to be, say if I got the back one set at 4 degrees, I want that one set at 4 degrees too. So what I did is I determined the height of the brake or the control arm heim joint off of the jig, and then I made another fixture, and I'll show you that real quick. That's this little dealio here. And it went on the jig like that.
and it held the heim joint off of the jig at the correct height and the correct angle that I needed. I could adjust it up and down or slide it forwards and backwards, and then once I got it where I needed it, I just clamped it. Okay, hopefully that makes a little sense there. That's how I did it. Then that helped me determine these tabs, which were different because of the fact the frame rails kick up in the front end. They had to be a custom-made tab, and like I say, I super gusseted everything on this front end too because I didn't want them tearing off. I mean, a lot when you're going out and doing these big money bracket races and stuff, we're not always racing on like NHRA Division prep tracks or National Event prep tracks. They can have some rough return roads and stuff, so you want to build it so it don't fall off. So that helped me determine that. And then what I did is I set the outside tab in place, made that tab, bolted it all together and tacked it. Then I was able to build the inner tab and just put the gussets on from there. And as you can see, I've got those 3/4 inch tubing gussets to keep the tabs, those long tabs, from moving around when you're jamming on the brakes and stuff. Okay, we got that done. Both sides are all tacked together. I've not finished welded anything. I know that the angles on everything are right. My rotors are still plumb. My caster's still set at 10 degrees. Everything's good there. Then that comes to the point to mount the rack. Okay? And I have a little fixture. Now, I'm not going to go get it, but I'll tell you about it. Basically, it's a piece of saddle tubing that hose clamps to the rack in the middle, and it's adjustable in height, and it clamps on the top of my jig. That way I can raise and lower the rack where I want it, and then build my tabs and everything else. This one down here is a little hard to see. I've got a piece of 1/4 inch plate that bolts on the bottom of the rack mount there, and then there's a piece of heavy wall 3/4 inch tubing that welds over to the frame. First thing I do is center the rack, so I know that it'll turn equally both ways. This is like a 4-turn rack, so you just, turn it one way to the other, mark the center, and then you're ready to mount the rack. What you're really looking for when you're building a car like this is to eliminate bump steer totally. You'd want that tie rod end. I'm going to get you where you can see it. That tie rod end should fall in line between the control arm bolt and the pivot here. I can't do that because the rack's not wide enough. So you compensate for that because of the length of the tie rod will help that, okay? With a different strut, like a short travel strut, you really eliminate bump steer. With this one, it's sort of tough. You just do the best you can. They make rack extensions and stuff like that, but we didn't need that for this car. We just didn't need it. Then what I do is I'll cut my tie rods, existing tie rods off where when I'm on the rack, set my heim joints and cut my tie rod tube so it all slips together, okay? So I've got the swedge tie rod tube slipped over the original tie rods on both sides, and I also set the rack in there so that it's level across the top of these bolts so I can get that shaft underneath the motor plate, okay? Then I should back up here, I'm sorry. Before I clamp my rack in place, I pull a string from steering arm on this side to steering arm on this side, so I can get an actual center line of those holes on my frame rails. You can't see them because the rack's over the top of them right now. But that tells me the center line of those bolt holes on the frame rail. So I mark them, and then what I do is I measure a 1/2 inch forwards, and that's where I mount the center line of my rack, a 1/2 inch in front of that hole, just to try to keep a little bit of an angle in there. You don't want too much, because then when the wheel turns left or right, it can flop over on you. You can over center the steering arm and really screw things up. But I try to, that's just how I do it. Okay, so while I'm doing that, I'm looking to make sure I clear all the pulleys and everything else. I can get a belt on there. And then what I do is I set the tie rod angle the same as the control arm. So if the control arm's at 4 degrees, I set the tie rod at 4 degrees as well. Since I can't get my ball joint out in line with all that stuff, I set my tie rod at the same angle. Okay? Then that determines my rack height. Then I go ahead and make my mounts. Everything's plumb with the world, and as you can see, it clamps on the passenger side and it bolts on the driver's side. And that gets, you know, that gets all my steering components in a row. These AFCO struts, they have an external cartridge. I've built a saddle. They're clamped on. I'll try to get you around there and show you that. They're clamped on back here, just a saddle that holds them, because the headers come out through this hole here. They go out through the fender. And then I modified the front end mount, the existing front end mount, so that it would fit in this car. Like I say, still have them on the radiator. We're waiting on that. That's basically how I do a strut front end, okay? Now let's talk about struts. These are great for drag racing. Strange struts, I use them too. Strange are like a 3.5 inch stroke strut. They offer a Camaro spindle for the bigger brakes like this. And then they offer an Anglia spindle, which is lighter for the spindle mount wheels. Like I say, if you're not building a 2,000 or under, 2,500 or under pound car, don't use spindle mount wheels. Just the brakes are horrible. You're counting on rear brakes only when you're doing that, because the puck's only like 1.5 inches in diameter, the brake puck. You know, and these use a regular big pad on them. Most of your stopping's done with your front end. 60% of your stopping's done with your front end, so you want good brakes up front. Stuff that don't wear out, like you're putting pads in twice a season. With my top sportsman car, it was that way. I was putting pads on it twice a year, you know. Car was fun, but high maintenance. Anyways, strange struts, lightweight, aluminum bodied, just like these. Got a press-in steel spindle. I'm not a huge fan of them, to be honest with you. They're reasonably priced. Like a Bear strut kit, I think, is like $1,600, and I've used a lot of them because they're affordable. Okay, I don't really care for the valving, but there's companies out there that can revalve them for you and make them a lot better pieces. Davey Conley, Progressive Suspensions, he does a lot of work with them. He does everything, so awesome guy. Great guy to know when you're trying to really fine-tune a car. These here, for what we're doing, they work just fine. They don't need any revalving or anything else. Extremely controllable. Okay, so we got past the strange strut. Like I say, they're 3 to 3.5 inch stroke. Got the AFCO here, it's a 5 inch stroke, a little bit more, but they work good for this type of car. Something that needs front suspension travel, this is the way to fly on a drag car, okay? Now listen to me, I'm saying drag car. If you're building drag and drive cars, don't use aluminum bodied struts. Do not do it. Sandtough makes a steel bodied strut. Only way to fly if you're building a drag and drive car. The Sandtough strut, Ronnie started building his stuff basically for pro mods and pro stock and stuff like that. It's a really, really good piece. Okay, they ain't cheap, but like I say, if you're driving it on the highway, you want a steel bodied strut, not an aluminum bodied strut, because these things will break. And like I say, spindle mount wheels, yeah, it's definitely a no-no. You'll rip them right off the front of the car. Bolt-on wheels, you're good to go. Penske makes a great strut, but it's like on the upper end, you know, you're talking probably $3,500 a strut. If you're building a, you know, super quality, high-end car, complimentary car, pro stock, Penske's the way to fly. But what we do here is all budget-minded, so I like these. I have a good relationship with Eric at AFCO and love their products. And like I say, we were going to use these on Rob Mosier's Camaro, and the chassis builder talked him out of it, which I don't know why, but these became available, and I told Rocky, I said, man, let's use these on your car, give them a good shot. So I have a feeling you have good success with this. And as you can see too, this car's got a motor plate. The car previously had the motor mounted in it, so what I had to do, once I got the front clip cut off, is prop the motor up in the car so I could get everything in the right place and make sure the headers went out the holes in the fenders. You can see them over there. Everything all lined up, and then that determined my engine height. So we got that set. Then what I do is, it had a motor plate in it, but you can just go off the block, and I set like the back edge of the motor plate even with that tube, that 1.25" tube on the side. You know, I just sort of measure over to the down tube and the frame rail with a straight edge and put a line there, and then I make that the center line of that 1.25" tube. I install that tube, and then I make the motor plate fit in the hole, and then I use 2-inch flat stock on the back side and fully welded that to that 1.25" tube, and then I put a little seat down at the bottom about 1.5" so that you can set the motor in on those tabs and then put the bolts in. You're not trying to wrestle the bolts in and wiggle the motor around. It just sets in and the bolts fall in. I don't drill the holes until after it's all set together and done. So, and typically 4 3/8 bolts does the job. Anyways, once I get everything where I want it, let's put it this way, where I get everything where I want it with the exception of the motor plate, okay? I got the motor setting in the car and all this tubing's in it, and I know like my control arm angles are right, my struts are in the right spot, you know, caster's right. Then I finish weld everything. I get everything finish welded, and then I put those diagonal gussets in down there to keep the front end from wiggling. It also gives me a little bit of a mount for the struts, or the rack, I'm sorry. Like I say, next thing I'll do is mount the radiator and overflow, stuff like that, and Rocky can take her home and paint her. I just figured I'd show that to you real quick, what I had going on there. I know this isn't gasser stuff. Got me some really awesome wheels at the swap meet over in Lima. 4 aluminum slots, 10s and 3.5s. Fenton gyros on the front. I don't remember what the backs are, but they're nice wheels. I got a great deal on them from Linegar in town here. So, anywho, you've seen my fixture. My next video is going to be on setting frame rails in Jerry Dean's car. I got the front frame rails built. Of course, I piled a set of headers in there just to get them off the floor for a minute. Wanted to get that done. Like this week I'll be working on that, and I'm going to start hanging the doors on the Henry J, so you can see some of that, how I do that. A little different with a Scott Rod's body than anybody else's, so I'll show those and then I'll show Jerry's doors. But that's what we got going on in the shop. Like I say, I know it's not gasser stuff, but it never hurts, because everybody usually has 2 cars if they're like me. So anywho, that's all we got. I wanted to show you that. I'll talk to you next week.